Hello everyone. In this session we are going to discuss about email and PGP. First we'll see email. Various business services are now offered online through the client server application. The most popular forms are web application and email. In both applications, the client communicates to the designated server and obtains services. While using a service, from any server application, the client and server exchange a lot of information on the underlying intranet and internet. We are aware of facts that these information transactions are vulnerable to various attacks. Network security entails securing data against attacks while it is in transit on a network. To achieve this goal, many real-time security protocols have been designed. Such protocols need to be provided at least the following primary objectives. The primary objectives are the parties can negotiate interactively to authenticate each other, establish a secret session key before exchange the information on the network, exchange the information in encrypted form. Interestingly, these protocols work at different layers of networking model. For example, S-MIME protocol works at application layer. SSL protocol is developed to work at transport layer, and IPsec protocol works at network layer. In this session, we will discuss different procedures for achieving security for email communication and associated security protocols. The method for securing DNS is covered subsequently. This is the application layer. This is the network layer in which secure application TCP/IP physical network. In the application layer security, in the transport layer security, application secure session TCP/IP physical network, and in the network layer security, application TCP secure network IP physical network. Email security. Nowadays, email has become very widely used in network application. Let's briefly discuss the email infrastructure before proceeding to know about email security protocols. Email infrastructure. The simplest way of sending an email would be sending a message directly from the sender machines to the recipient machine. The simplest way to send the email would be sending a message directly from the sender machine to the recipient's machine. In this case, it is essential for both the machines to be running on the network simultaneously. However, this setup is impractical as users may occasionally connect their machines to the network. Hence, the concept of setting up email servers at arrival. In this setup, the mail is sent to a mail server which is permanently available on the network. When the recipient's machine connects to the network, it reads the mail from the mail sent. In general, the email infrastructure consists of a mesh of mail servers, also termed as message transfer agents, and client machines running an email program comprising of user agent and local MTA. Typically, an email message gets forwarded from its UA, goes through the mesh of MTAs and finally reaches the UA, that is user agent, on the recipient machine. You can see the email infrastructure in the diagram, that is, in the email message gets forwarded to its UA and goes through the mesh of MTA and finally reaches the UA. That you will see in this diagram, email infrastructure. The protocol used for email are as follows. Simple Mail Transfer Protocol (SMTP) used for forwarding email messages. SMTP, Simple Mail Transfer Protocol, used for forwarding email messages. Post Office Protocol POP, Post Office Protocol, and Internet Message Access Protocol IMAP are used to retrieve the messages by a recipient from the sender. The Post Office Protocol POP and Internet Message Access Protocol are used to retrieve the messages by recipient from the server. Next heading is MIME. The basic internet email standard was written in 1982 and it describes the format of email message exchanged on the internet. It mainly supports email message written as text in basic Roman alphabet. By 1992, the need was felt to improve the same. Hence, an additional standard multi-purpose internet mail extension, MIME is nothing but multi-purpose internet mail extensions, was defined. It is a set of extensions to the basic internet email standard. MIME provides an ability to send email using characters other than those of the basic Roman alphabet, such as cyclic circle used in Russian, the Greek alphabet, or even ideographic character of Chinese. Another need fulfilled by MIME is to send non-text content such as images or video clips. Due to these features, the MIME standard became widely adopted with SMTP for email communication. Email security services. Growing use of email communication for important and crucial transactions demands provision of certain fundamental security services as follows. These are the email security services, that is confidentiality, authentication, integrity, non-repudiation, proof of submission, proof of delivery. Confidentiality. Email message should not be read by anyone but the intended recipient. It is very confidential, should not be read by anyone but the recipient, the particular recipient. Authentication. Email recipient can be sure of the identity of the sender. Email recipient can be sure of the identity of the sender. Integrity. Assurance of the recipient that the email message has been altered since it was transmitted by the sender. Non-repudiation. Email recipient is able to prove to a third party that the sender really did send the message. Proof of submission. Email sender gets the confirmation that message is handed over to the mail delivery system. Proof of delivery. The proof of delivery, sender gets a confirmation that the recipient received the message. The proof of delivery is that sender gets the confirmation that the recipient receives the messages. These are the 6 services. Email security services are there: confidentiality, authentication, integrity, non-repudiation, proof of submission, and proof of delivery. Security services such as privacy, authentication, message integrity, and non-reputations are usually provided by using public key cryptography. Typically, there are 3 different scenarios of email communication. We will discuss this method of achieving above security services in these scenarios. One is one-to-one email. One-to-one email is nothing but in this scenario, the sender sends an email message to only one recipient. The sender sends an email message to only one recipient. Usually not more than 2 MTA are involved in the communication. You can see in the diagram, the user sends an email to only one recipient, and usually not only 2 MTAs are involved in the communication, not more than that. Let's assume a sender wants to send a confidential email to a recipient. The provision of privacy in this case is achieved as follows. The sender and receiver have their private public keys as S private, S public, and R private, R public. S private, S public means senders, R means receivers. The sender generates a secret symmetric key KS, that is symmetric key for encryption, though the sender could have used receiver public key for encryption. The symmetric key is used to achieve faster encryption and decryption. The sender encrypts message with key KS and also encrypts K5 with public key of the recipient. The sender sends encrypted message and encrypted KS to the recipient. The recipient first obtains KS by decrypting encoded KS using his private key. The recipient then decrypts message using symmetric key. That is the sender and the receiver, and the sender sends the message through the internet with the public and private keys, and the receiver receives the message with the encryption in secret key. If the message integrity, authentication and non-repudiation services are also needed in this scenario, the following steps are added to the above process. The sender produces hash of the message and digitally signs this hash with his private key. The sender sends this signed hash to the recipient along with other components. The recipient uses public key and extracts the hash received under the sender's signature. The recipient then hashes the decrypted message and now compares the two hash values. If they match, the message integrity is considered to be achieved. Also, the recipient is sure that the message is sent by the sender. And lastly, the sender cannot deny that he did not send the message. That is non-repudiation. One to multiple recipients emails. In this scenario, the sender sends an email message to two or more recipients. The list is managed by the sender's email program UT plus local MTA. All recipients gets the message. That is one to multiple recipients. Let's assume that the sender wants to send a confidential email to many recipients, say R1, R2, R3, so on. The provision of privacy in this case is achieved as follows. The sender and all receivers has their own pair of public-private keys. The sender generates a secret symmetric key KS and encrypts the message with this key. The sender then encrypts KS multiple times with public key of R1, R2, R3, getting R1 public, R2 public, R3 public. The sender sends encrypted message and corresponding encrypted secret key to the recipients. For example, recipient 1 receives encrypted message. Each recipient first extracts the secret key by decrypting encoded secret key using the private key. Each recipient then decrypts the message using the symmetric key. For providing the message integrity, authentication and non-repudiation, the steps to be followed are similar to the steps mentioned above in one-to-one email scenario. 1-to distribution list email. In this scenario, the sender sends an email message to 2 or more recipients, but the list of the participants is not managed locally by the sender. Generally, the email server maintains the mailing list. The sender sends a mail to the MTA managing the mailing list, and then the mail is exploded by MTA to all recipients in the list. In this case, when the sender wants to send a confidential message to the receiver for a mailing list, say 1, 2, 3, exam, so on, the privacy is ensured as follows. The sender and all recipients have their own pair of public-private keys. The exploder sender server has pair of private-public key for each mailing list. The sender generates a secret symmetric key and then encrypts the message with this key. The sender then encrypts KS with the public key associated with the list obtained. The sender sends encrypted message The explorer empty encrypts the using the private list and obtain the secret key. The explorer encrypts the secret key with so many as many public keys as their member in the list. The explorer forwards the received encrypted message and corresponding encrypted secret key to all recipients in the list. For example, the explorer forwards the encrypted message to R1 to recipients 1 and so on. Next, this is about email. Next one is PGP. PGP is pretty good privacy. Pretty good privacy is an email encryption scheme. It has become the de facto standard for providing security services for email communication. As discussed in the previous above, it uses public key cryptography, symmetric key cryptography, hash function and digital signature. It provides privacy, sender authentication, message integrity, non-repudiation. Along with these security services, it also provides data compression and key management support. PGP uses existing cryptography algorithms such as RSA, IDEA, RD5, etc. rather than inventing the new ones. Working of the PGP, hash of the message is calculated. MD5 algorithm, hash of the message is calculated. Resultant 128-bit hash is signed using the private key of the sender. The digital signature is concatenated to message and the result is compressed. A 128-bit symmetric key is generated used to encrypt the compressed message with IDEA. Ks is encrypted using the public key of the recipient using the RSA algorithm and the result is appended to the encrypted message. The format of PGP message is shown in the following diagram. The IDs indicate which key is used to encrypt Ks and which key is to be used to verify the signature on the hash. In PGP scheme, a message is signed and encrypted and then MIME is encoded before transmission. PGP certificate. A PGP key certificate is normally established through a chain of trust. For example, A's public key is signed by B. Using this public key, B's public key is signed by C using his public key. As this process goes on, it establishes a web of trust. In PGP environment, any user can act as certifying authority. Any PGP user can certify another PGP user's public key. However, such a certificate is only valid to another user if the user recognizes the certifier as a trusted introducer. Several issues exist with such a certification method. It may be difficult to find out a chain leading from a known and trusted public key to desired key. Also, there may be multiple chains which can lead to different keys for desired user. PGP can also use the PKI infrastructure with certification authority and public keys that can be certified by CA, that is X509 certificate. This is about PGP. Then in this session we discussed about email and PGP, email security, the protocols used for email and MIME, what is a MIME and what are the email security services and what are all the three scenarios of the security services, that is one-to-one email, one to multiple recipients email, one to distribution list email, one to many. And what is a PGP? PGP is an email encryption scheme, pretty good privacy, and what is the working, how the PGP will work, working of the PGP. and what is about PGP certificate, which is normally used to establish through a chain of trust. This is about this session. Thank you.